Okay, hello again, and welcome to the final stage of our deploying an app to AWS, a deep learning app that we built, trained in the last stage, compressed into TensorFlow-like format. We're now going to deploy that, and let's, as usual, at the start of each stage, we start with the architecture diagram here. It's not perfect, but it gives you an idea of the main components involved in each of the steps. So we're here, final stage. The main thing we're going to need here is some config around the S3 bucket that gets provisioned using the serverless template. So we'll start with that serverless template, and I'll draw your attention to how that is set up. Also, how the Lambda function, which we haven't really touched on yet, gets set up, and really you can see everything within the AWS console that is provisioned when that deployment's done. The S3 bucket, we need to, as I said, make some config changes so that it can render the image in the actual app itself. That's a screenshot you see there at the end. There's also a small change we need to make to the API gateway to allow image formats, specifically PNG and JPEG formats, and that will complete it. The process, that'll be it done. So that's the architecture. The steps, as normal, are on the website. So if I bring those over, usual place, blog, stage 6. You'll see here, these are, we're going to add an extra step actually before the first sub-step here, just to give you a flavor of how you might want to make changes to the app yourself beyond this video series. But essentially the main steps to do the configure, making the S3 bucket that serverless provisions public. We've already actually shown you how to do that in the previous stage when we created that temporary bucket for the model. This is the actual S3 bucket that serves the entire app that we're talking about here. So we'll do the same thing in substep 1. Then substep 2, we have to set the correct S3 bucket access. That's to allow the API gateway to talk to the S3 bucket and save and bring back the image in order to do the inference. So we basically have to add in a policy to the S3 bucket to do that, to enable that. We also need to update our bucket name. The main Python script at the moment has a placeholder like this. I'll show you that when we get there. Clearly that's not going to work. It needs to be the correct URI for the bucket, or the actual bucket name that we're going to replace with. And then finally, that last step is actually away from S3. It's around the AWS API gateway. The endpoint is by default will not accept PNG or JPEG images, so we need to update the types of images it can process. It is to do indirectly with transfer from S3, because S3 by default will store images in a binary format. That's no good though for rendering on the actual app. So we'll change that, redeploy it, and all things being well, that will be it. We'll see our app up and running and test it with some test images. Okay, so I mentioned we're going to add this extra little bit at the start of this final stage, just so that you can see how you might want to make changes indirectly. It also relates to my deployment here. I want to create a completely fresh deployment. At the moment, I'm using an old Lambda function and ECR repo. So what we're going to do is go to the serverless template in GitHub. So this is actually rolling back to stage 4. If you're, trying to, you should try to bookmark some of these links, but essentially, if you forget, go back to the blog page on the website, and it's stage 4 we're talking about here. If you remember, we cloned this repo And when you sign in here to GitHub, one of the nice tricks, if I just log in, one of the nice tricks you can do here once you're logged in is edit your code. Now, I don't recommend doing it on mine. Obviously, here you would do it in the forked version that we created in stage 4. If you press dot on that project folder, it will actually take you into Visual Studio for GitHub, and it's much easier to manage changes, delta changes to your code base from there quickly, and then pull them in to our EC2 instance. Okay, so I'm just going to put these two hopefully together. Okay, so we've got our EC2 instance open plus our Visual Studio for GitHub here. Zoom in a little bit. Okay, so serverless, our YAML file. This is what I'm going to change here. As I said, I've already got a serverless template set up, and when we did the deploy in stage 4, that used the existing container as it should. But for the purposes of this video, I'm going to create a completely new one here. So let's just do like that, new. I'm going to save it. If you go to source control here, you'll see that the changes are reflected there. You can put a little note there as to what we've changed. So updated serverless service name, and then just commit. Okay, now back in EC2, again, probably a good idea. I've still got mine open, but if you want to exit that, it's a good idea to refresh this from time to time, reopen or reconnect to EC2. Okay, and then we're just going to drill down into the right folder here. So CD Lambda, use tab again to autocomplete. Here is the level that we cloned from GitHub. So we actually just need to do a pull request here, git pull, go back to GitHub, and if you need to get the repo address, just go to repo is one way you can do it. Code, copy that there. Right click, paste it beside there. So we're going to, okay, so we've pulled the changes in to serverless, basically just that name change of the actual service, so that in my case, I'm going to create a completely new deployment. In your case, you don't need to do this step right now, but it gives you some idea of flavor how you want to may want to make changes later on. If you just want to check the actual file in our EC2 Linux instance here, you can do also cat serverless YML. That actually will display, if I spell it properly, it will display the contents of the file. Okay, and you can just check there that yes, indeed, it's reflecting the new name for the service. Now go on and proceed with the rest of the steps. Okay, so if I go back to the steps here, That was step 4. We don't want that. We want to go back to step 6. Stage 6, sorry. Okay, so we need to do a deploy before we do anything here. And then I'll show you in the console what exactly has been deployed, and then we'll make those further changes. So if you just type out ls deploy, we're in the project level here where the serverless YAML file is, so that's the right level. And remember, that's may take you shouldn't take much longer than 5 minutes, so let it run. Okay, you can see there that deploy failed. Most of the time, those fails are related to space, as this one is. So use the same Docker prune command that we ran in the previous stage 4. It's all there on the web page. Just paste that in. Are you sure you want to continue? Yes. Okay, just make sure you type in Y. In my case, I originally typed in Y and must have pressed another key, and it didn't actually clear any space at all. Run it again. It should come up with a message saying, displaying how much space you've reclaimed. In my case, 4.4 gigabytes, so it's significant. And then cycle back using the up key, SLS deploy. Okay, so that deploy is done. Again, that probably takes the longest time in this whole video series when you do a serverless redeploy or a new deploy, as we've just done there, about 5 minutes. You've got your, in my case, a new URL. So either you can do it the way I've done it here, or you can just retain the one that you've already done in stage 4. It doesn't really matter. What we're going to do now is just check what's happened there, because go under the hood a little bit in the console. If you go back to AWS, let's have a look at our Lambda function first of all. Now, Lambda functions obviously can be used for running Python code or other code. Here, we're really using it to host this app, including all the source code. You can see there is the CloudFormation template. If you open that up, zoom out a little bit here, you should see a number of resources, including the Lambda function, the main Lambda function for this, and the serverless bucket, as well as an API gateway. So we're not really looking at the Lambda function directly here, but it's good to know under the hood that is what kind of holds this whole thing together and allows each component to work with each other, including the API gateway where the endpoint app is hosted. If I go back, we're interested in this S3 bucket now because the steps, these last config steps we need are to do with that, plus the last one on the API gateway. So let's go to our bucket. Okay, it's taking me straight in there. If you have in the background, as usual, the steps that are involved here, we need to make this bucket public. So as we did in stage 5 with the temporary bucket for our model, this bucket, which is not a temporary bucket, it is used every time the app's running to transfer the image. We need to make this public as well. So if you go to permissions here, the permissions tag, you see under block public access, it says on. So that's the default, because we created it effectively from the serverless template. We didn't have that chance to override it, but we do now. So if you go to edit, uncheck that option, okay, and save changes. It doesn't mean it's unsafe. It just allows that app to be used by an end user, right? You need an end user to use your app, so they need to be able to do that transfer of the image for inference. So just confirm that, and that will update. So that is sub step 1. We've also got to set, that's not enough here because we need, there's an interface from S3 to the API gateway, essentially that the container image, the ECR container image uses as the endpoint. Now, those two things need to talk to each other, need to be authenticated, and therefore we need to get and put requests both to be enabled. So what you're really doing here is putting this bit of code inside the existing bucket policy. If you scroll down, you see that's the policy at the moment. We want to edit it, replace all of that, Control A, Control V with our version. And we also need to update this is a placeholder URI. We need to update that as well. So that, relatively straightforward. You can just copy, sorry, it's not a URI, it's a ARN, Amazon resource name. Just copy your ARN for your bucket there and replace the bit before the / and the star, like that. Okay. Just make sure it's got get object and put object for S3. The policy actions we can perform. Save changes. Okay, so if at first the screen doesn't show a red button at the top saying publicly accessible, just refresh the screen, reload it. That's got to be there. It should be there as long as you've unblocked and so enabled public access, as well as added that policy from the web page that I've just shown. Okay, so we've got the red badge there. If you go back up to the bucket level, in my case, I've got a few other buckets, but you can see that it's public. The one that we've just created through that serverless template, CloudFormation template, is just been made public, and that's what we need to enable the transfer of the image in the deep learning app. Okay, that's sub-step 2. Sub-step 3 is to take the bucket name into our main Python script. The best way to do this is using our GitHub Visual Studio Code interface, and then just do a pull request. So if we go back in there, our bucket name, if you go to properties, the bucket name is the ARN there. So copy that. We still have our somewhere, I think, here we go, our Visual Studio open. This is Visual Studio for GitHub. If you've forgotten how to open that, just go into your GitHub, log on, press dot on your project folder, and it will open magically Visual Studio for code. Nice trick. So back in the Explorer window here, this change we're making to our main Python script here. So this is essentially the driver for the deep learning model. If you scroll down, there's a few functions there with callbacks. That's essentially the Flask part of our app. Also, we'll call in the main code the inference step, and that is the inference step is under the Python subfolder there, dlmodel.py. But this is the main Python script that we want to change here, where it says your S3 bucket. Okay, we need to paste that in like that. Now, there is another change I need to make because I made a completely new deploy, if you recall, and it's using a different serverless service. So if you go back to, for example, our bucket and top level, And if you drill down a couple of levels there, the folder is called serverless Flask container new, in my case. If you've just picked up the existing code base and not changed, as I did at the start of this part of the video series, then you don't need to change anything. But in my case, I need to reflect that here where it says serverless Flask container. Should be new. Don't worry about that. That is essentially where the user's uploaded image to perform the inference gets put back into S3. So that's fine. Save that. Go to your source control here. You see that has some changes in it. So bucket name added to main.py. And we can see as well serverless service name updated as well. Okay, that, and it should disappear. So we now need to go back into EC2, do a pull request. You might want to come out of this for now. Reset the connection. Okay, we need to CD into our Lambda folder again, and then we want our pull request here. So get pull, copy the URL from GitHub, or if you've got it anywhere else, web page, it's also there. Paste it under your EC2. Just check it should only really show that one change, right? So main.py looks good. That bit's done. What we did was update the bucket name there in substep 3. The last part of this is to define uploaded images for our app and the API gateway now. So we'll do that, and then we'll do the redeploy. We could do a deploy now, but it's better to complete all these changes, and then we'll do the final deploy. So go back to your AWS console. If you type in the search box API gateway, just open that in a new tab. Okay, just check here. In my case, I've got a few of these, but this is the one that's just been created. You can see by the date. Okay, under settings, we want to scroll down to binary type. Settings, right at the bottom here is binary media types. So you need to add this. Okay, and then we're just going to paste this format in like this. So that allows PNG image, JPEG formats, normal image formats to be interpreted. Okay, paste that in without the space at the end, save the changes. Okay, and then we can go back to EC2. Okay, and do a deploy. Just go up, SLS deploy. You may get another space error because we're right at the margins here of what's enough. 500 megabyte slug size. We're quite close to that with TensorFlow CPU library, with the model itself, all the other libraries. If that's the case, just do a Docker prune and redeploy. Okay, our redeployment is done. Again, it's a bit shorter this time. As in my case, it's the second deploy. URL shouldn't have changed because we haven't changed the service name. Let's go and have a look because we've made all the changes. In theory, our app should now run. So just copy the URL there. You want to bookmark that as well because it's your app web address. Might be a few seconds just to load. Okay, there's the app loaded. It might take a few seconds again just because we've made that change. This time we've got the deep learning model behind the app. So let's test it. There's a link on the web page to some test images, so you can just download them to your local to load them up. Upload image. Let's try, first of all, this one's a bit dark, but we'll try it as PNG image. I'm going to run the script. Okay, so as expected, in that kind of final deploy, we've got a few errors here, or at least one. So what I've done here is tried to upload an image. This one is an intersection sign. Okay, you can see there we've got a very dark image. That is a intersection sign. If I run the script, though, the problem we've got at the moment is this. So there's a few things you can do here. Right click, inspect, open developer tools, for instance. Have a look in the console. You see we've got a couple of failed error messages. This is not a big deal. This is an icon that shouldn't really be in there in the code base. And it's not opening the load source map. No big deal with those two things. So that doesn't really help us. I'm going to close this for now and go back to EC2, because what you really want to do with this kind of thing is more often than not gets the logs for the deployment. And you can do that with this command. Here, I'm going to type out serverless. Well, in fact, let me get into the right folder first of all. We need to drop into project level here and then run serverless logs force, and the name of our app, you might see some references to app. In our case, we haven't called it app.py. Our main Python script is main.py, so you need to make sure that says main there. Make sure you spell serverless properly as well. And hopefully this sheds some light on what's gone wrong. So you can read, there's quite a lengthy error message there. What I like to do is try to scroll right back to the start of the message. There we go. And it's got invalid bucket name. Okay, that's quite clear. So what I've done is actually I've included the full ARN name rather than the bucket name. We didn't need this bit here. So that's a relatively easy fix. If we go back to our Python script, I'm still in GitHub, Visual Studio here, remove the bit before the actual bucket. That is the actual bucket name there. Save that. Go to your source control. So removed ARN from bucket name. Okay, that. Back in EC2, we'll need to do a pull. In fact, we can press up here to go back and grab the last one. There we go. Yeah, that's the change that we wanted to the main Python script. We probably want to do a prune here, purge. I suspect we'll get a space error issue. Usually after one or two deploys, it will fill up already. So just prune, confirm yes. That's going to clear 4 gigabytes. And then we will do another SLS deploy. While that's running, another thing you can do just for housekeeping, back in AWS console, if you do ECR, you'll see that the container images start filling up as well. You don't need to clear them as often. Here's my latest container, 26th of May. Okay, so you can see there, you've got a couple in there. The untagged one is an old one, so you can probably delete that. You typically, when you're making changes, you quite quickly accumulate 10 or so of these images. Just make sure you're deleting them from time to time. Let's see, after every 5 or 10. That'll clear up some space as well. Make sure you keep the latest one, and then go back to EC2. So we're rebuilding, redeploy. Okay, the redeploy is done. Let's check again. Copy the URL, or if you bookmarked it, just go back. Okay, there's the app up and running. Let's try again. Same image we had before, an intersection sign. Script, okay, we've got another error. You can check dev tools, but I suspect it's probably, let's have a quick check. Same error messages there. So back in EC2, cycle back to get our logs. Okay, so this last error message we've got refers to, as you can see here, pill unidentified image error. That is the pillow library in Python. Refers to how images are interpreted and ultimately converted into tensors. So what we've done here is, if you have a quick look at S3, for example, you will see that the image actually is created under one of the subfolders of your S3 bucket. So in my case, if I open it here, drill down a couple of levels, you'll see that is the image, and it gets refreshed every time a user interacts with the application. What I found after that error message came up is that if you open it, the image wasn't rendering. Typically, that refers to a problem with the repo, ECR repo. So I've gone to ECR. If you choose your repo and open it, and then just delete the old images like I described earlier from earlier stage of the build process, and delete them all at once. I've already done it and redeployed, but just type in delete, that will get rid of them. Roll back to the repo level, click beside your ECR repo, and then also delete that. Clear the whole thing, rebuild. So back in your Linux instance, your Linux EC2 instance, you scroll down here. After doing another prune, we've done a rebuild here, and then if you now go and open the app, the URL won't have changed. So if you've got it saved somewhere, great. Copy that in. Okay, sometimes loads quite quickly if you're just making minor changes in the deploy. And I'm going to open up this image here. So this is our first one. We're testing it with an intersection sign. That will call the inference model, and you can see that it's predicted it's an intersection. It's not very sure. It's 47% sure. Because quite a dark image, difficult to distinguish between it and other categories. Let's try another one. Slippery road is a bit clearer. And if you run that, you get a pretty certain classification that is slippery road. Bear in mind that we trained that model on Colab using GPU pretty quickly. The whole thing, we used early stopping criteria, so you might want to, if you want to get better results, better certainty or probability, then you can deploy a more sophisticated model or train for a bit longer. Perhaps use some more data samples. Certainly you want to be looking at the test set, because we only went through it and trained the model without any validation. One more check here. If we put in, it's a pedestrian sign, let's check that one. There we go. So not quite sure about that one. Maybe confused with bikes or some other similar road sign. But that's it. That is, we're done. This is deploying an app to AWS, a deep learning app. We trained the model in the last stage. We exported that model, compressed it so that we could host it in our code base on AWS Lambda. And we've now completed the process. There was some final config around the transfer of those images to and from S3 and making sure that API gateway talks to S3 and is able to comprehend the image that's uploaded here. So I hope that's been useful. Thank you for listening, and stay tuned for further blogs, thought leadership walkthroughs in the coming weeks and months ahead. Thank you.